Welcome to physics. We are going to study the laws of nature and our universe. These laws apply to everything, including ourselves. So physics is like getting to know each other, right? Is an experimental science. We like to observe phenomena in nature and we want to quantify. We want to create models, theory, laws to be able to predict. We want to land on Mars safely and come back home. How do I measure this iPad? In the past, it was a little bit subjective. In Italy, I use meter. In the United States, you use inches. Then, in 1889, in France, they came up with a convention called Système International. The time will be in second, the length will be in meter, mass in kilogram. Unit of measurement always in a square bracket. What is the second? Originally was tied to the length of the day. Today is the atomic clock. And the meter originally was a tiny fraction of the distance between the North Pole and the equator. Today, I love this one. The distance, the meter. Yes, the meter is based on the distance that light travel in a vacuum in this little tiny fraction of a second. And how about the kilogram? Is still in France under vacuum. If you go, check it out. But we are looking modern way to quantify the kilogram. Power of 10, I want to point out pico, nano, micro. Look at this Greek letter elongated mu and milli. Minus 12, minus 9, minus 6, minus 3. And the very famous kilo, mega, gigatera, 10 to the 3, 6, 9, and 12. Conversion unit, how do we go from inches to centimeter? That is practice, practice, practice. Just to refresh what you already know, please go on study area, please click on tutor, and you will have a lot of great examples. And video. I love the first one, driving on the Autobahn. Here's a screenshot. When you click play, the video will show you how to go kilometer to meter, meter to mile. It's a lot of fun also because you will have a different heritage. Instead of Italian, maybe it's going to be British, maybe it's going to be German, American. So enjoy and celebrate this variety of culture. Now, don't worry, no stress. During the test, I will always provide you with the conversion unit. Always use 2 decimal places. Finally, nature is going to be quantified with vectors and scalar. Vector. We put an arrow on top, they have a magnitude and a direction. Woohoo! Means here's home and you're going to go to the gym, right? So this is your direction toward the gym. You're walking a distance or a displacement of, let's say, 60 meters. So 60 meters is your magnitude, and you're also giving me a direction. So when you think about velocity is a vector, acceleration another vector, a force is a vector, even your weight is a vector. So what is a scalar? Is just, in simple word, a number. A scalar only is the magnitude. So the magnitude of velocity is your speed. Magnitude, that will be the abbreviation of velocity. Another scalar is time. Or another scalar is a temperature, is just a magnitude, just a number. And the scalar I like is a mass, because mass is the number of atoms in your body. So mass is just a number of atoms in your body. With vector, we can have fun adding them together. For instance, we are going to add A plus B. Stay with me. A and B. When you unite the beginning of A to the end of B, you have the sum C, which points always toward the longest vector. In this case is B. You can have fun also adding these three vectors together. For instance, you can slide B down here, right here, and then you can find the sum, which is a D, sum of A and B. Then you can sum D with C to find the resultant R. Little bit of trigonometry. You remember what is the sine, cosine, tangent of theta. But what I want you to do is a refresh, so automatically we can go into practice great problem from the end of the chapter. So here's an easy way to remember. Adjacent side, I'm going to call it A. Opposite side, O. Hypotenuse, H. So adjacent to the theta angle wants the cosine. The side of the triangle that is opposite wants the sine. All right, let's compute. Let's do quickly. A adjacent side equal what? Hypotenuse always. Sine of cosine is adjacent cosine of theta. Oh, yes, always hypotenuse. Uncertain? Sine or cosine? You see it's opposite. Just plug in sine of theta. Finally, we get to vector component. You have a beautiful vector A, ready to be split into its component. Here it is, component A of X and component A of Y. Now, why we have a sine and cosine? Because this is a right triangle right there, right? I'm going to actually use a green highlighter so you can see I'm reasoning on this right triangle. So, according to what we just refreshed, this side, A of X, is A cosine of theta because it's adjacent. And the Y component, which is also this one, right, is the same. A of Y, since it's opposite, wants the hypotenuse. This will be H, your hypotenuse. Since it's in opposition, you remember it's going to be the sine of theta. So now that you have the component of vector A on the x and y axis, how do we compute the magnitude? It's super easy. Remember, it's Pythagoras. A of x, this component square, and that component square under the square root. What is the direction? Well, is the tangent of theta. But I like to write it down like this one, because the direction is theta, the angle. It's going to be the inverse of the tangent of the vertical A of y component over A of x. So look how much we already did. Don't worry, we are going to practice this concept in problem, and we are going to add more detail. Again, the best way for you is to create a summary where you collect all these formula we cover in the theory. So you keep this summary in front of you when we go in Let's Practice. I usually walk Teddy, my neighbor dog, with a force of 20 Newton and an angle of 37 degrees. I want to ask you, how much force do I need if I want to walk Teddy with a force parallel to the floor? And how much do I need if I want to lift Teddy perpendicular to the floor like this one? So when I take Teddy, my neighbor dog, for a walk, I pull on the leash with a force of 20 Newton at an angle of 37. I want to know how much force I'm gonna get to have Teddy to move forward parallel to the floor, or to lift Teddy up straight vertically up to the ceiling. Let's see, let's compute A, the force that is parallel to the floor. So I'm gonna create my Cartesian axis, this positive vertical axis pointing up, and positive x. I want to visualize the force of 20 Newton. This is 20 Newton, my force. And the angle is always measured counterclockwise from the x-axis of 37 degrees. So in part A, I want to find the parallel to the floor. So this is what I want to find. I call it f of x, and I'm going to apply trigonometry. F of x will be the hypotenuse f multiplied the cosine of the adjacent angle, that is 37 degrees. Since is a 20 Newton force, multiply cosine of 37, the final answer is a 16 Newton force. How about if I want to lift Teddy straight up? What does it mean? I lift Teddy up like that, means I'm gonna compute the vertical component of f. F of y, which is also this one, f of y, is gonna given by the hypotenuse f in red, multiplied, since it's opposite to the angle, the sine of 37. So when you plug in, like we did before, 20 Newton as a measure of force, the y component final answer will be 12 Newton. In this problem, we are going to analyze two rocket engines being fired simultaneously, exactly like it's going on at the NASA Stennis Space Center, where they are testing a rocket engine called the J2X. You can see two engines being fired in this video. What if one of these engines is, however, fired directly forward, and the other one is actually fired at 32.4 degrees above the x-axis? What will happen? We want to find the resultant force, which will tell us where the rocket is gonna go. So let's analyze this problem and let's see what happened. Gonna place the video to the side. So in our problem, you have a force 1 that is 725 Newton, and it points toward the forward direction of the positive x-axis. Force 2, I'm gonna do my Cartesian axis. Force 2 is a little bit less strong, only 513 Newton, and is fired at 32.4. So we want to find the resultant, the magnitude, and direction. The magnitude right there, and the direction will be actually the inverse of the tangent, right? Vertical over horizontal component. But in any case, I'm gonna repeat this important equation while we are solving the problem. Okay, the first step we want to do is to do the components. So the components of F1 and F2. Let's see these components. For F1 on the x-axis, I already know it, right there is a long 725 Newton, being the Newton, the unit of measurement of a force. Do you see a vertical component for F1 on the x-axis? No, there is not, because F1 is only parallel, is on the x-axis. So there is nothing pointing up vertical to the ceiling. So 0 Newton. How about for force 2 on the x-axis? Here we have a right triangle. So I'm gonna do the component. I'm gonna build my triangle. And in blue, right here, you will have force 2 on the x-axis. The triangle I'm gonna analyze is this one. All right? So F2x is gonna be given by the hypotenuse f of 2 multiply cosine of theta, because is adjacent to the angle. I'm gonna plug in the value Newton multiply cosine of 32.4, and this one will come up 433 Newton. How about the vertical component of f of 2? I'm gonna do it in green. It will be this one, which is the same right here. Actually, I like it to use it in this position because I can reason on the right triangle I have highlighted in yellow. So it will be given by the hypotenuse, which is f of 2, since it's in opposition, is the sine of theta. Let's plug in. F of 2 is your hypotenuse, this one. You know how much it is given by the problem. And this will come up to 75 Newton. Second step is to focus on finding now the component r of x and r of y of the resultant. So r of x will want all the x component. We have only 2 forces, so we are in great shape. And the ry component, again, the y component of the 2 forces. Okay, so again, x and x, x and x, and the y component. Let's plug it in. f1x is a 725, and f2x is total. And for this one, it will be 0 and 275. So we found the x and y component of the resultant, therefore the magnitude is super easy to find. Magnitude of the resultant is the square root of the x component square. So, very simple, let's plug it in. 1158 Newton. Don't forget to square. I always see students forgetting to square under the square root. Final answer 1190. I always like to frame the final answer so I can find it right away. How about the direction? The direction is the angle theta, which is the inverse of the tangent vertical over horizontal. Let's do it. All right, r of x and r of y are right here. All right, and this angle will come out to be 13.4 degrees. Frame it and it's a final answer. Are we done? Not yet, because I want to see where the engine is now going now that I have the resultant and the angle. So I'm gonna draw. And these are the steps, the classic step: magnitude, direction, and drawing. Cartesian axis pointing up x. So here I have an angle that is really 13.4, very, very little. So probably, I'm not in scale, but you get an idea. That's the angle of 13.4. And the resultant, which I'm gonna do it in red, is right here. This is the resultant, which is long 1190 Newton. So this is a beautiful, elegant problem. I'm gonna also show you something else. Because you remember we had the forces as follow. Was 725 Newton, right? For force F1, and then you had this force F2 that was 513 at an angle of 32.4. I want to show you how to do the resultant using the parallelogram graphically. Parallel to F1. I'm gonna draw a parallel to F2. So look, the resultant will be exactly the same. So now I even know that the value, the magnitude of the resultant is 1190 and it points at an angle of 13.4. What does it mean? It means that that rocket will take off almost kind of parallel to the floor, so they need to adjust and calibrate those two engines. So again, to summarize, this is a classic problem, and we put in practice the theory you already know. We have a boulder which has 3 horizontal ropes, so the boulder will be at the origin of the Cartesian axis. And they pull, as in figure, you can see A, B, and C forces measured in Newton. We want to find the components of the resultant of each pull, then the magnitude and direction, and finally, like you already learned, we are going to draw something. All right. So in this case, I'm gonna break down the first step, A, so that we are gonna find the components X and Y of A, B, and C. I like to really draw all the time each force. So for A, I have 100 Newton, vector A of measure 30 degrees. I'm gonna build my right triangle, and in blue right here will be A of X, in green will be A of Y, which remember I like to place it here. A of y pointing up. I'm gonna reason again on this triangle so I can apply trigonometry. For a of x, I know it's gonna be given by the hypotenuse since it's the adjacent cosine of theta. So it will be 100 Newton multiplied cosine of 30 degree. Final answer. For a of y, the one I did in green is opposite to the angle sine of theta. Final answer 50 Newton. Now let's go to B. B on my Cartesian axis points right there like that, and it gives an angle of 30 degrees. So for B, I want you to see the different possibility we have, but it's gonna be always the same. Now the angle is always computed theta counterclockwise from x-axis. So it's depend on which triangle you want to use. Now, if this is a vector B, I'm gonna show you that this could be B of x, and this one will be B of y, which I like to place right there. So if I'm reasoning on this right triangle, then the angle I wanna find is this one. And how much is this angle? Well, I know that is 90, right, minus 30 equals 60. Or you can even compute the counterclockwise to there. So it will be 90 plus 30, and then since it's 180, it will be 180 minus 90 plus 30 equals 60 degrees in any case. All right. So I know the angle is 60. Let's compute the component. B of x is adjacent, so it's gonna be cosine of theta, and B of y is opposite B sine of theta. If you plug in all value, you will have the final answer. However, I want to show you something very important. A little bit more detail, properly done mathematically. Do you notice that B of x, right there, is pointing in the positive x? Here is the positive x, or is pointing in the negative? B of x is pointing in the negative x-axis. So where do I have to place a negative sign? It's right here. All right, very important. Indeed, when you plug in all the value, I'm gonna just do for this one, B is 80 Newton. The negative sign, because B of x pointing the negative x, and this is cosine of 60. This one will come out indeed a negative 40 Newton. This one, B of y, points up, so no negative sign. If you do the math, will come out 69 Newton. So I'm gonna put this one in a frame because it's an important concept. This one and this one, little bit more detail. Let's move on to the last vector. These are my positive and Cartesian axis, and this one points, C points down here, is long 40 Newton, that's a vector C, and they give this angle as 53 degrees. So again, you have a variety of possibility, but I'm gonna show you that this will be C of X in blue, and this one will be C of Y, right? Pointing down, which I'm gonna bring it over here. So this right triangle, it's really handy for us to compute the component. Now let me ask you, for C of X, is it positive or negative? Well, C of X, it points into the negative, so is indeed a negative. Let's not forget the sign, negative C, and then is adjacent to the angle. So it's going to be minus 40 Newton cosine of 53. And this one will come out to be minus 24 Newton. How about C of Y? Positive or negative? Well, this is also negative, so I need, because it points opposite, downward instead up, vector C, since it is opposite sine of theta. So let's plug in. And also this one will be coming out a minus 32 Newton. If you were thinking, well, but I want to use this triangle, well, it will be exactly the same reasoning, except that you will be using an angle of 90 minus 53, this will be an angle of 37 degrees. So I want you to redo it on your own using the trigonometry applied to that red angle. So part 1 is done. Let's go on to part B. Part B wants to find the magnitude and the direction of the resultant pull. So I'm going to do the resultant. I know that it will be given by A of X, B of X plus C of X. And the vertical Y component will be A of Y plus B of Y plus C of Y. All right, so let's plug in all the value we already found. A of X right here, plus B of X, which is a negative value, so I'm gonna, let me erase, I like neat. All right, so A of X is 87 Newton, then there is a negative 40 Newton, and another negative 24 Newton. So the total 23 Newton for component X of the resultant. Let's do the same here for R of Y. Here A of Y, this is a B of Y, and this is a C of Y. Let's not forget this minus 50 Newton plus 69 Newton minus final answer 87 Newton. So we found the x and y component of the resultant. In part C, we wanna find the magnitude of r, which you remember is nothing else than the square root. Let's square it. Final answer 90 Newton, and I want you to frame the final answer. How about the direction? It's the angle theta is the tangent to the minus 1, always vertical component over horizontal component. So the tangent inverse of 87, and this one comes out an angle of 75. Am I done yet? No, what do I miss? Is to draw the resultant. All right. So both component, the x is 23. I'm not in scale, okay? And the y is much longer, is 87 Newton. I'm gonna do parallel right to the x, parallel to the y-axis, and the resultant is the diagonal. And I even know how long it is 90 Newton, and I even know that counterclockwise from the x-axis it forms an angle of 75 degrees. All right, now it's very important that you write down r of x, a small x component, right? A of x, small x. I don't want you to really write it like that, because this means you multiply r by x and is a totally different phenomenon. I don't even know what is. So make sure that the component, even a of y, is written very, very small. That's why I like to use a super fine pencil for physics. You will feel like Raffaello or Donatello or Michelangelo writing this algebra, trigonometry in so clear and so perfectly. So a fine point pencil with eraser is the best for physics. Stay